Probably
that
not.
you know of.
You might leave them behind.
And by the time we're actually ready to start colonizing other planets in earnest, most of the manual labor is going to be done by machines, and so the guy that actually
Somebody's got to maintain the machines.
and that'll be a high skilled job. It's not going to he's not going to be some he's not going to be a dumbass.
So,
okay, and so you're not going to be taking any of the other thing about it too is creating your elite society. When you're talking about the kind of money they're talking about, to create a whole new solar system in our solar system, with that kind of money, you could very easily just buy a continent here on Earth and just move everybody out of it.
But you're still on Earth, so you're still subject to a certain bozo in a certain country who decides he wants to set off nuclear bombs, and he's just fouled the pool for everybody.
Well, that can happen. Yeah, that's true.
You don't have that problem if you just leave the pool and go to your own, to go to the one next door.
I suppose it seems like kind of an expensive solution to me, but I suppose that would work.
And that's why you're the riffraff that's getting left behind.
Probably, yeah. I know.
Okay, so who is doing this? Who is the group that's going to do this?
Is it the Illuminati?
I have seen talk that it could.
Well, hey, Illuminati and a second son.
Illuminate.
There you go.
No, I have seen that it's been the Illuminati have been pointed at. I've seen that it might be the Freemasons. I've never seen it the Shriners or the Moose. I'm pretty sure they can't make the trip.
Not the Elks Club, yeah.
But there's a whole nother group that I came across this. I don't know if you guys have ever listened to Clyde Lewis. He's got a syndicated radio program, and he's here in Portland, but on his site they started talking about this Jason Society.
Oh yeah, you don't know Jason?
I didn't know Jason, and so I was really, really kind of intrigued by this entire thing made up of super smart scientists that were doing all of these things, and supposedly Jason was originally created by President Eisenhower, and I'm just gonna read this is all in quotes here. He put together the Jason Scholars to investigate all things cosmic, including extraterrestrials, UFOs, and the so-called breakaway group that would have to evacuate the planet to start civilization elsewhere. Mm-hmm. That's what Jason was all about.
Yeah.
Is yes, yeah. You're right. Is so.
And there are other groups out there that are seriously discussing moving humanity. Not all of us, but starting us, off somewhere else in Mars or new stars, wherever, to get humanity off the Earth. Not entirely, but move us around, spread us out, disperse
well,
us.
and the theory of using like hive ships or colony ships is not new.
Yeah.
I mean, it's been around for a long time.
That's how we got to America.
And actually, I'm going to reveal it now. We are on one right now. They just haven't told the dumbasses. So just keep it on. You guys know this too, obviously.
It's really the Matrix.
Yeah. Our listeners are smart enough; they know about this. Nobody else does. So.
Okay, so the Jason Society, they're going to figure this out, and they're going to jettison all the good people to this new planet. But what is going to stop the rest of us here on planet Earth from cobbling our own rockets together, Clampett style, and going to the new good neighborhood, moving in, and just turning the whole thing south on them?
Well, they probably have big lasers and stuff like that.
Well, that's one of the things.
When you show up, they'll probably just vaporize you.
I think they have dimonium shells.
Are you talking about the Dyson sphere?
Nope.
Okay, different thing.
Yep.
Okay. Well, no, what I was getting at was that if their plan to do this works, they're gonna cause some cataclysmic problems throughout the rest of the solar system, which is gonna stop us from being able to get ourselves there, because when this new star goes off, it's going to exert a lot of gravity.
Yeah.
And it's going to start sucking asteroids out of the asteroid belt and pulling them towards itself, which is then going to make the trip between the two. It's going to be, going through a minefield, and then a lot of those asteroids are going to be coming and falling onto this planet, causing just mayhem. Plus, we're now going to be blasted with radiation that we weren't set up to deal with in the first place.
Also, we're all dummies.
So basically, we're all just going to melt, and then we're like, we don't have to worry about them. It's not like they're ever going to be able to make it here.
Yeah, I don't. That's not going to happen though, because the plan is to ignite a nuclear reaction without changing the mass of Jupiter.
Mm-hmm.
So it's actually not going to It's not going to muck with the orbital mechanics of the solar system very much at all.
That's possible.
But it
The-
will
I mean,
muck
it's-
with
the
it.
only-
It
the-
will change it.
No,
I
it
think,
won't.
Joe,
I mean,
it's-
the mass of Jupiter won't change. It just becomes an illuminated object rather than just one that reflects light. Now it creates its own light.
Mm-hmm.
But the plan is not to change its mass at all.
But
So-
okay.
And so, I mean,
I was gonna-
if you really want to turn it into a star, you have to add a ton of mass to it, more mass than can be found in the solar system. Yeah, so that's the only way to do it. And that will definitely mess up our orbit. And
But in
it'll
the
do all
fake
kinds of
science
stuff to it.
sense, right? The
In the fake
pseudoscience,
science, then when it
in the
becomes a
conspiracy
sun,
theorist
suddenly
science.
it has more influence, orbitally speaking. Okay.
No,
Maybe
no,
it's the
I'm
solar
saying,
winds.
I'm saying the opposite of that. I'm saying that I agree that according to your, the fake theory, right? Not the fake theory, but the fake science behind it. Yeah.
The conspiracy.
Yeah, all they're
science.
doing is setting off a nuclear reaction.
It's not going to change its
It's not
mass.
going to change
No,
anything.
not really.
So so it's still fine. They're just trusting that we're all too dumb to figure out how to get over there.
They
which
will
is
have taken
probably
all
true.
of the people who can operate a spacecraft with them.
They will.
Yeah. Actually, we know how to get there now. It's just it's too expensive.
Yeah, and
Yeah.
they're going to take all the people with the money, so it doesn't really matter.
Yeah.
But I agree that if we're doing it the real way, that it's going to be a problem.
Well, let's talk about the real way.
Yeah.
Let's talk about Let's talk about the approved science. That's not the alternative science. Let's talk about the approved actual science that we get from all of the people who study this stuff and seem to be the scholars that most people refer to. Let's start with that.
Talking about the people that are in the employ of big oil, all those people that are.
You mean Jason members?
That
No,
have
not the
paid.
Jason members.
Yeah.
We're talking about the guys at NASA, the guys
Oh,
who are
those guys.
instigating the
Yeah.
cover-up.
The guys at NASA are part of Jason.
Maybe they are.
Of course they are.
Yeah.
If they're involved in the cover-up of Project Lucifer, they are part of Jason.
Okay.
Yeah, no doubt.
Let's go backwards here a little bit. Let's roll back and let's talk about one of the first problems we have, which Joe was just talking about, or briefly alluding to, which is the source of this nuclear fusion process, which is the RTG.
Yeah.
RTGs are not atomic warheads.
No.
No.
They are not something that is weapons-grade plutonium. That's actually something very different. RTGs use plutonium-238, which is called reactor grade. A nuclear weapon uses, I love how clever this name is, weapons grade plutonium,
Oh, duh.
which is plutonium-239. And the other difference is that inside of weapons grade plutonium, there is also a very, very small, like single-digit percentage of plutonium-240, whereas reactor grade has more plutonium-240 in it. Now, that's an important thing to understand because it is the plutonium-240 that makes it harder to sustain a chain reaction in the nuclear process.
Which is why you might want to, put it on something you were blasting into space. You'd want something fairly stable
Something that, that would not
in
be a
its
bad
tiny
thing.
little space instead of something that might, if got rubbed the wrong way, might just
Like a
explode.
kablooey.
Right.
Especially if you're shooting it into space through our atmosphere.
Yeah, they actually, the way they do it in the RTGs is they put them all in like their own separate little container made of iridium and some other stuff that are basically kind of unbreakable. So they just to actually reach what's called critical mass.
Because
That's not
it's
the same as
240
going
though.
critical.
Well,
Right.
it's the
Well,
combination.
240 helps to make it more stable.
Right.
But also, even if it was like weapons grade, there wouldn't be enough of it to really, I think, be in any given space to actually be enough of a critical mass to turn into a weapon. Even if you crash
But it might
compress
explode.
or whatever. Not necessarily
No,
exploding.
probably not.
It could escape its container somehow and scatter around and poison a few people. That's about it.
So here, to answer your question, could it explode?
Yeah.
Okay. If I understand correctly, it's the plutonium-240 that has kind of a stabilizing effect on the nuclear process. But in 1962, the United States did conduct an underground nuclear test with non-weapons grade plutonium, so reactor grade Pu-240. They were able to get it to explode. It was very difficult and it had an extremely low yield. So even though they got it to go off, it wasn't as if it was, oh my God, we found the mother of all explosions. This sucks. This is way less than what we already know how to make.
Okay.
But of course, you gotta remember too. We only know what's in those RTGs because that's what they've told us.
And that is
True enough.
a beautiful point, Joe.
Yeah.
I wanted to make sure that we at least got that across, that this is everything that is, I'm going to use the word, I'm going to say documented officially.
For the sheeple out there.
Maybe we're being lied to. Maybe
course we are.
our friends here in the next section are right, and what is on the schematic is only a portion or actually completely wrong. I don't know.
Totally wrong.
Totally
100%.
wrong. Well, it could have some of it, but it's just, they've scaled it in some way. But what Joe talked about before was the fact that it's so difficult to get the plutonium in the RTG to go off, and that is because of the fact that each of these bits of Pu-238, I've seen it described, they're about the size of a marshmallow, and not the little ones that you put in your hot cocoa, but the bigger marshmallows.
The jumbo ones?
Yes, a jumbo
Those are good
marshmallow,
ones, yeah.
which is then enclosed, as Joe said, in iridium. That is then put into a shockproof graphite impact shell. That is then put into what they call a general purpose heat shield module. And I mean, they are so multi-layer wrapped that they cannot come into contact with one another. So, I mean, if something goes wrong, let's say an asteroid comes flying by and smashes into the spacecraft, rather than jamming them all together, they are going to scatter in the wind like packing peanuts.
Okay.
They're going to spread about. They shouldn't be colliding with each other. And even if they do, they're so wrapped up they can't fuse.
Yeah.
So they cannot create that critical mass.
And so they can't go critical, and so
Yeah. So they can't get a large enough mass together.
But of course, that's only according to what they're telling us.
Correct. Now the thing to remember is that, and this is why it's kind of difficult to make a fusion reaction or a nuclear reaction happen in general, is that you need to be able to implode all of the material around the plutonium equally and at the same time. So it's from all sides. If you only do it from one side, it's not going to react. It's not going to create that fusion, so it's not going to go off. So again, that's why the packing peanut method is so good. And it's actually really hard to create this perfectly ignited system. We did it. I mean, in the 40s and World War II, the U.S. dropped Fat Man on Nagasaki. It used this implosion trigger mechanism, but it took the U.S. many, many years to get it right.
Those, by the way, were not fusion bombs. Those were just atomic bombs.
Right, but they used that implosion method.
One of them did. The other one used the...
Yeah, Fat Man.
Yeah, the other one used the gun method.
Little
the gun
Man.
barrel. Yeah, it used the gun barrel.
Yeah.
Yeah.
So, I mean, they didn't do it the same the whole time because it's not easy to do.
Yeah, they were essentially the prototypes. And yeah, it's like they actually had these special little switches and everything that out of themselves, a non-exportable item and everything, just to make sure that all the charges go off at precisely the same time. Because that's what it is. It's just a sphere of explosive, all these different charges with all these wires and switches and igniters going to them, and they've all got to go off at precisely the same time.
If there's a delay, it doesn't work.
And believe me, you can wire it up as good as you possibly can, and they're actually not going to go off at precisely the same time, like if you and I do it.
Yeah.
So here's a question. If you shot something into, like, Jupiter, for instance, is the pressure going to be equal from all sides at a given time?
More or less.
Theoretically.
Yeah.
And
that's why the science, that's why Jupiter is one of the places that they use this idea for, because theoretically, as it falls through the atmosphere, miles and miles and miles and down, the pressure is going to be uniform on all sides.
even behind?
Yeah, on all sides.
On all sides.
I mean, it's like the pressure on a deep sea. What is the Alvin and the autonomous
Trieste and all that stuff?
Yeah, the autonomous robots that go into the Marianas Trench and stuff like that. The pressure on all sides is basically the same.
Here's the next question,
Yes.
then. Follow-up question. The little containers that they put them in, how precise is that, right? I mean, human error is a thing. Manufacturing defects are a thing. So are they all so uniform that they would also deconstruct at the same rate?
So our
Probably
friends,
not. They're not built to that kind of specification.
our
standard.
friends who are putting out all of this are under the belief that the intense pressure is going to jam everything together at such a great force
That it won't even matter.
That it won't matter, and basically the iridium is going to separate naturally away, if I understand it correctly.
Oh, is that how
and then
it's
the
gonna work?
next layer of the packaging peanut is going to separate, and they're going to kind of condense, based on their own densities. They're going to reorganize, and I mean, it doesn't make sense. It's weird science. Some of it does make sense. I will give them that from a layman's perspective. Some of it makes sense, but some of it doesn't follow the rules of logic that we've learned.
Well,
Yeah.
and I don't think that. Let's face it. If NASA really intended to do what they're talking about here, then they wouldn't have separated all that great plutonium out in all these little containers. They would have put it all together where it could actually be touched off. If
And
that was
again,
their,
as
if
you
that was their
said,
plan.
maybe they are.
But I don't think that I don't think the pressure on Jupiter is ever going to be big enough to actually touch off a fusion reaction.
Yes.
I don't believe there just isn't enough pressure there.
So let's let's do this real quick, because a lot of this science of how the sun works, it's miles above my pay grade. But we talked about it a little bit earlier, and I'm not going to go. I mean, I've got some stuff written here about the combination of helium and the proton to proton chain. Like, we don't need to go into all of that as I read this again. Really, what we talked about before is it's got to have enough gravity to hold that fusion reaction to itself and not let it expel everything out. So the science says that Jupiter, even if it did create a sustained reaction, would not be able to hold it all in. It would burn up, and
It
it
doesn't
would
have the mass.
expel it all into space.
That's why it needs to be like 80, 90 times bigger than it is. That gives it the gravity to hold it all together at the center and sustain a reaction.
Yeah.
Yeah. So sorry, Jupiter. That's why you're a failed star.
If you had just studied for the SATs,
That's
you
right.
would have made it.
No, she should have just stopped losing weight.
Yeah.
Stop dieting, Jupiter.
Yeah.
We
Have
need you to
another
be
donut.
big.
Yeah.
Okay.
We need you to be a thick planet.
Yeah.
Okay, so we've talked about why they're doing this, Project Lucifer. We've talked about the official why it can't happen science.
Real science.
The why it can't happen science. I'm not
Okay.
going to call it that, because, we never turn away a theory.
You're right.
I mean, it's one of the things we do. It's silly, but we do it. Okay, so we're going to go into the conspiracy theorist section of their science.
Why they say it's real.
Why they
Yeah.
say it's real. So if you remember, we talked about the 1962 nuclear test with reactor-grade plutonium. Well, they say, look, it proves that you can light this stuff off, so it is entirely possible.
Would it be safe to say that the similarities are like saying, oh, hey, you can light this sparkler off, or you can light this mortar firework off? You can do both,
Yeah.
right?
Yes.
One is going to create a sun. The other is what the U.S. did underground. Would that be a fair comparison?
And that is in the most general,
really basic
way to say it. That is not a bad way to look
Okay.
at it. Okay,
Because it is technically the same thing, right?
Yep.
It
So
is a
it
proof of
could
concept.
ignite, but it wouldn't sustain for very long, and it wouldn't be very powerful. So yes,
'Kay.
I'll give you that.
Okay.
Yeah, I think that one of their things they're saying is that Jupiter has more of the constituent elements just right there present in the atmosphere to create this chain reaction that we don't
Sure.
have in our atmosphere.
Yeah.
I don't know.
I don't either.
Yeah. Well,
And
Yeah.
I don't know
even
if
if
they know.
even if
Yeah.
Jupiter went off, I don't know how long it could sustain the reaction. But
That's the big problem.
let's move back. Remember, we've already talked about this a couple of times with Galileo.
Yeah.
We crashed him into Jupiter.
Yeah.
I don't know why it's him. Maybe
Galileo.
Galileo crashed into Jupiter.
Galileo was a dude, so we'd call him him.
Okay.
Figaro.
Well, at that time, there was a guy named Jocko van der Warp. Did I say that right, Joe?
I
Yeah.
have no idea. That works
Okay.
for me, though. I like
All
it.
right. Well, he went on Coast to Coast AM. We've talked about them before, the radio program that talks about all of this kind of stuff. And he said that the 2000 crashing of Galileo...
2003.
Yeah, I said 8, didn't I?
You just said 2000.
Oh, well, it's the 2003 crashing. Well, not to be confused with the 2000 crashing that didn't actually happen.
Right.
Of course, 3 years too early.
2003 crashing of Galileo into Jupiter. He's the one who seems to have initially claimed that the plutonium in the RTGs was going to implode.
Mm-hmm.
His appearance on that show was then picked up by another guy named Richard Hoagland, who said, and Richard Hoagland, by the way, believes all things space conspiracy, from what I can gather. He believes that all of the things that we see in the photos of Mars are actually old structures from a Martian civilization. Sure. I'm generalizing here, but those are things that he says. Oh, by the way, he also says NASA's covering up that ancient civilization.
Of course.
But he heard this stuff from Vanderwarp, and he locked on. He got on board that bandwagon, and he just broadcasted. And he seems to be one of the major proponents of the idea that the black spot that happened a month after Galileo crashed, he's the one who seems to be the source of the reporting that was proof that a reaction happened. It just wasn't sustained. So we actually can trace this back a little bit to somebody to figure out at least where some of these stories come from. You know, how often do we talk about this? We have no idea who it was. We can't figure it out. I think we actually have the source for once.
I think you do too. I mean, I'm puzzled by some of the things that he says, but you think you do have your source, yeah.
Yep.
Although, you know, if you look back far enough, you might find somebody speculating somewhere in Popular Mechanics way back when that maybe we can turn Jupiter into a second sun. You know, I mean, the idea may have been floating around for longer than we know. I mean,
yeah, true.
I'm not really sure.
Well, for this to have happened, the explosion on Jupiter would have needed to be 2,800 times the size of the biggest nuclear bomb we ever set off on this planet, which, by the way, was 50 megatons.
That was a big one. That was one the Soviets set off, right?
Yeah, they set it off in 50... I want to say 52, but I don't want to lock into that because I don't remember the exact year. But it was I almost said a different word. It's really big.
Mm-hmm. Yeah,
really big. So that yield is phenomenal, and the math, again, like a lot of this, the math is a little weird, but he's saying that NASA's lying, and they are basically floating these intensely powerful warheads through space under the guise of being objects of observation for other planets.
Well, but why did it take a month for us to observe is it because Jupiter's just so big that that's when it came around?
It took. So if I understand, if I'm reading into what he says, it took about 2 weeks for it to fall deep enough into the atmosphere of Jupiter for the pressure to become great enough to ignite the plutonium.
But I'm so bad
and then it
at
took
science.
another 2 weeks for that to radiate back up for us to be able to see.
Yeah, that just doesn't make sense to my brain, but that's why I will be one of the people left behind.
That's okay. There'll be lots of us. It'll be a party.
Yeah.
But he's saying that he's talking about 2,800 times the size of that 58 megaton bomb, right?
Right.
I haven't done any actually calculation to figure out how much plutonium you'd have to have.
More than I believe you can pack on these little spacecraft.
Well,
It is an amazingly pure grade of plutonium that is so reactive.
It would still have to be a lot more than 34 pounds, I think.
Oh yeah. No, I'm not in disagreement with you at all there. It would need to be a bunch more.
Yeah, I'm not, for a bomb that size, I'm not sure that we have a rocket right now that could actually get that to Mars, or excuse me, to Jupiter.
Yeah, no, we don't want to put it into Mars. We want to put it into Jupiter.
Well, actually, I'd really
Mars will just fly apart.
I'd really actually kind of prefer to nuke Mars, because that's the planet that I'm actually really more interested in terraforming.
Well, nuking it is not going to help that process.
Elon Musk has got this cool plan actually to nuke Mars. He does. I'm not joking.
He does actually have a cool plan.
I know, but I can't help but laugh at it. Okay.
Yeah.
Okay.
It doesn't involve flying Galileo into it, though, so that's the good news.
Sorry, I can't help but start laughing. Hoagland he's also the source that seems to feel that the whole crashing into Jupiter instead of the moons to not contaminate them, he seems to be the source of the one saying, well, that's a total lie. I don't know why, but he is. But the last thing I want to talk about here is we talked about earlier, we've only discussed Jupiter this entire time. And soon the spacecraft Cassini is going to be crashed into Saturn.
I know.
Because
makes
it
me
is
sad, really, kind of.
Yeah, it's been up there for 17 years. I mean, it's been there for a long time. It's running out of power. It's at the end of its lifespan, and they're going to do the same thing with it as they did with Galileo. People are now saying, well, they're trying it again. They're going to a different planet because it didn't work so well the first time. Except there's a massive... I can't get across how massive this problem is. It's about 90 times more massive than Jupiter. Is that Saturn is smaller than Jupiter.
It's also not a gas giant, is it?
Yes,
it's a gas giant.
It is?
It is a gas giant.
Which one am I thinking of?
I don't know.
You're thinking of like Uranus,
Neptune
probably.
or something like that,
Neptune,
but it is smaller on magnitudes of scale. I think it's Joe. Do you remember?
It's about in terms of mass. It's about a third Jupiter's size.
Okay, thank you.
In terms of mass, which is what we're
So it's even smaller. So it's going to be even harder for this to actually work if indeed this was their plan. Like, this is the most screwed up plan. If they're like, well, we're going to do it again, but let's go to the one that's even harder this time.
It's almost like it's not their plan.
It's almost like they're trying to fail.
Yeah.
Kind of there are some cool, interesting, ambitious plans out there. Like there was one that NASA just floated in February this year, which is basically to put a satellite in the L1 orbit between the Sun and Mars. And essentially, the reason Mars doesn't have an atmosphere is because
it's too close to the Sun and it's burned off.
No, Mars is further from the Sun than we are.
Oh, I'm sorry.
Venus actually has more of an atmosphere than we do. They have a very dense atmosphere.
Okay, anyway.
Yeah, but anyway, you're thinking maybe Mercury, but
it's probably
essentially Mars's magnetic field died about 3+ billion years ago.
Because it didn't have as much iron in its core, is that right?
I'm not sure exactly why.
Okay, I remember reading about this before.
That could be why, but essentially, our magnetic field, believe it or not, it protects us from the solar wind. It diverses, and that's what keeps our atmosphere from being stripped away like Mars's atmosphere has been. So there's a plan, but it's just an idea. So to put this thing in orbit between the Sun and Mars might be prohibitively expensive. But if, on the other hand, we could do it, it'd be
What are they putting between? I guess I missed.
It's going to generate a magnetic field.
Okay.
That will essentially protect Mars from the Sun, from the solar wind. And it's a really cool idea if it's actually, if we can actually afford to do it, because once we had that protection for Mars's atmosphere, then there's volcanic activity on Mars. It would generate an atmosphere in actually a fairly short amount of time. And so between that, maybe dropping a few nukes here and there to kind of encourage the polar caps, ice caps to melt a little bit, that kind of thing. Mars could actually be more habitable in not a long period of time.
What's not a long period of time?
Decades. I mean, and we're
like
not talking
within a lifespan.
Yeah, we're not talking walking around on the surface without any sort of breathing aid or anything like that. I mean, as far as getting it to some sort of Earth kind of atmosphere, God knows how long it would take to get everything.
Centuries, if not more. But
but in terms of terraforming a planet, that's actually one of the quicker ways of going about it. Some of the other methods that I've heard about, and so it's a cool idea. And so there are ideas out there to create new. And so whenever I hear ideas like Lucifer, for example, I'm always kind of like, yeah, cool. Let's create some more habitable planets in our solar system.
Except for that one's a dumb one.
Well, that's a dumb idea.
Yeah.
It is. It is kind of a dumb idea.
I mean, and it's like we said before, even if Lucifer worked, I really still think that it's going to cause some serious problems inside of our own solar system. I mean, if for no other reason than the radiation.
Well,
because
that's not that much. I mean, it's far less than our sun puts out, and they're actually further from our planet. I mean, even its closest approach, Jupiter is still farther away from us than we are from the sun.
So what I mean by that is not necessarily the cancer-causing kind of radiation, boil my insides, but it's going to create probably some radiant heat, and the impact to our light and their day and night cycles could actually destroy this particular planet, because everything is used to a certain amount of time where it is on this globe, and if we suddenly add a second light source, that entire day-night cycle is going to be thrown into a tailspin.
I seriously doubt, though, that Jupiter, even if it became a little sun, would be any brighter than a full moon.
Well, for me, it's just all the unknowns.
Oh, yeah.
I mean, there's literally no way for us to know.
Luckily, it's
that
not
it
going
would
to
work.
happen anyway.
Right, which is great.
Yeah.
The only way
Don't
we're
have
going
to
to
worry
make
about
it, the only way we can make this happen is either go outside our solar system and get a huge amount of matter to bring back to